because really, I see Lightning Network as very disruptive for payments as a whole. So how do we make it so it works in as many cases as possible? And coming from that problem, that allocation problem, where do I put my Bitcoin in this complicated network? Well, we've been working with Stillmark very closely on the AI research to actually figure out what is the right answer to this problem. And it's a problem that's where solutions have been attempted before. We've really taken a step back to look deeply at the research and figure out what is the core problem. And the core problem is, how do I maximize payment throughput in the Lightning Network with as little Bitcoin as possible? So how do I make my Bitcoin go further to answer the payments problem? And that AI that we've worked on that is now going to be, published, is identifying bottlenecks and using a message passing neural network to actually bypass those bottlenecks within the network. And the result is that you have much higher payment throughput.
The integration between Bitcoin broadly, Lightning, use of payments. I envision, we talk about this often, that AI agents will be conducting the payment process themselves. AI agents, you can see getting a Lightning wallet and being able to execute on tasks using Bitcoin that have, to the point that we were talking about earlier, the final settlement, the non-recourse. So, which is important, I think, if you're the finality of that. But then even if you're looking at a larger payment, which I think is one of the problems that you're solving, by creating greater liquidity inside of the Lightning channels, it's like it can search for the most efficient and most effective payment without the bottlenecks.
We've tried so many different algorithms, and as we were attempting those algorithms, we found some surprising pieces that the Betweenness algorithm, in some cases, is worse than randomly selecting peers. So, while that was like the gold standard for actually making that allocation, some of our results were showing that it was not actually very good for the Lightning Network. Also, we were looking at, how do I keep this network decentralized? And so part of us doing that is actually removing the top nodes, saying, I don't want to connect just to the biggest nodes in the network. If I remove these nodes, how will the intelligence continue to operate? And what we found was that our message passing neural network performed much better when you were removing these top nodes. So what really excited us about this is it has a lot more potential to keep the Lightning Network decentralized, even if you're not going to be connecting to those, huge top nodes. Because a lot of people talk about the Lightning Network as this hub and spoke model, that, there's only going to be a few centralized hubs. And then they conclude the Lightning Network is centralized. Well, okay, if you're only using these algorithms that kind of force you to use these hubs, well, then you won't get a decentralized network. And so this is where we put a lot of effort into finding a different algorithm that actually supports decentralization and gets you that capital efficiency and that throughput, because we want the entire globe to be using Lightning and keep it decentralized. We don't just want one or two nodes to be absolutely crushing in on terms of routing to activity.